Well, I'd like to talk a little bit about residential wiring, like where the neutral comes from and how you can have 120 volts or 240 volts, like for your oven or something, and how you can combine and get it from your like surface panel or breaker box or whatever. So I wanted to start all the way at the beginning of the process, which is the generator. So this might be a coal powered, like make steam and spin a turbine, but ultimately it rotates a motor pretty much. It's a generator at a certain speed, and each time this bar passes the magnets, it would generate a electric current that is at the same frequency of however fast the motor's rotating. It's simplified a little bit, but let's say this motor's rotating 60 times per second, then each time it swings, the rotor swings past one of the poles, then that's when the voltage is at peak. So you will have a sine wave is generated as the motor rotates 60 hertz. Then from there we go to a step up transformer, so you can travel across the country. And so when you get into the neighborhood, you'll have a step down transformer. You'll probably actually have a couple step down transformers and like distribution transformers, but ultimately the final step down transformer is at the on the pole outside your house, and that will step it down to 240 volts. Now you'd be thinking, hold on, I thought all the electrical in my house was 120 volts. Well, what they do is they create a center tap on the secondary or the output of the transformer that goes to your house. So a center tap is basically just a wire attached to the center point of a winding. So this is just a single piece of copper wrapped around like a piece of steel that is representing a transformer. And if you literally find the middle of the wire and attach a third wire onto that and make a third leg, then you would expect that if the full voltage is 120, or sorry, not 120, 240 from one leg to the other, then the center tap is going to be half of that because it's only spanning half the wire. Then the next thing you have to understand is that it doesn't really matter which of the three that you call reference zero, because it's all just terminology. Electricity is like potential energy. So if you're standing on the second level of your house, then you have more potential energy than if you were in the basement, but less potential energy than if you were in your attic. So as far as voltage goes, 120 volts can only be positive 120 if that's referenced to some other location that is at a lower potential. And so pretty much what they do is they connect the ground, the earth ground, the stake into the ground, to the neutral leg. So the neutral line is always called 0 volts, or it's pretty much 0 volts with respect to everyone else's houses and everything. What that actually means is that the line 1, what I'm calling line 1, the voltage will be at a lower potential than earth ground. Simultaneously, line 2 will be at a higher potential, and you can visualize it like this. If this line in the middle was earth ground, which is not changing, earth ground is stable, then the line 1 voltage would be higher than earth ground, and the line 2 would be lower. Or line 1 versus line 2, it doesn't really make it, because they switch back and forth. But I guess I also drew these two to kind of show that at the beginning of a cycle, if line 1 is approaching negative, then line 2 is approaching like positive 120. But you can see once it returns to 0 during the second half of the cycle, now line 1's approaching positive and line 2's approaching negative. So, they switch back. But the difference is that if you were to overlay one on top of the other, they would look like they're opposite of each other, and that's because of the way that the center tap is done. In order for it to be halfway in the middle, you'd have one voltage will be exactly like say 120, it'd be exactly 120 lower, and line 2 is exactly 120 above. So what's the average of 120, or not the average, but the average, the middle point of 120 and minus 120? Well, 120 plus minus 120 is 0. So yes, 0 is halfway in between positive and negative 120. Okay, so that means that you have 3 wires coming out of your step-down transformer and into your house. And inside your breaker box, you can choose to wire some appliances that operate on 120 volt from neutral to, I guess that's line 2, or you could put them on like a different circuit from neutral to line 1, but you're getting 120 volts across. Now, it doesn't really matter to the devices which one you use, because they're pretty much just mirror images of each other. But if you need to power a device that is the full 240, you have both of those lines. It's just that you're not using the center tap to get the halfway in between. You go one to the other, then you get the full amplitude voltage of 240. I hope that that was explained clearly enough. I think that the hardest part about understanding voltage is the fact that, like, depending on where you were to move your reference point changes what you would call voltages. If we had chosen to attach the earth ground to, like, wherever earth ground is attached, that's always 0 volts, just because. If you were to attach earth ground instead to line 1, then line 1 would always be 0. Line 2, or sorry, what now is written as neutral, would be 120 volts AC, and line 2 would be 240 volts AC with respect to earth ground. But that's not how it's wired, so I hope that kind of makes sense, that because neutral is connected to earth ground, then line 2, even it's still single phase. This is all single phase. Technically, these two graphs look like they're out of phase with each other, but it's just more like this is like the top half of the graph, and this is the bottom half of the way that it's split.